All right. So we're going to start chapter 3, but first I want to do a quick review here of some things we covered in chapter 2 where we talked about atoms. So our ionic bonds are those bonds where electrons are given and taken between atoms. And so the sodium ion gives away its electron, it is transferred to the chlorine. And so because these electrons change hands, the sodium becomes positive, the chlorine becomes negative, and those opposite charges are attracted to one another. This forms an ionic bond, and we get sodium chloride. Covalent bonds, these are situations where our electrons are shared in order to make both atoms individually stable. And so here with this hydrogen ion, or these two hydrogen atoms, they're going to share this pair of electrons here. And so these electrons are going to orbit around both of these hydrogen nuclei, forming a covalent bond for this H2 molecule. Okay. The other things that we want to make sure we remember, these things that are important properties of water. So we have our cohesion, where water molecules stick to one another. And a lot of these properties are because of hydrogen bonds. So remember, within some covalent bonds, we have polar covalent bonds where those electrons are not shared equally. And so we get partial positive and partial negative charges on these molecules. And so we get these weak hydrogen bonds that occur. So water sticks to itself. If you drop a little bit of water on a table, it makes kind of a dome shape there because those water molecules are all sticking to one another because of the hydrogen bonds. We also have adhesion, where water sticks to other types of molecules if those molecules are also partially charged. Water can store a lot of energy without changing its temperature, which is why it takes so long to boil water. It has a lower density as a solid than as a liquid, so ice floats in liquid water. It dissolves lots of different types of molecules, and has a lot to do with pH, right? Whether something is acidic or basic. Okay. So now we can look at molecules, and we can look at when atoms bond, they form molecules. Okay. So molecules are just made up of elements. Sometimes these are elements that are the same in the case of H2 or O2, or sometimes those elements are different. And so here we have water. So this is a common name for this molecule here, H2O. I'm sure this is one we're all familiar with. What this tells us is this little subscript 2 down here tells us that there are 2 hydrogens and 1 oxygen bonded together, and that forms water. For glucose, we have 6 carbons, 12 hydrogens, and 6 oxygens altogether. Okay? And so these subscripts tell us how many of each element that there are in that particular molecule. Okay? So looking at organic molecules, these are molecules that make up living things. And so carbon is kind of the basis of all of these molecules. It's a pretty incredible element. And we see that all life as we know it is based upon carbon. Okay? And the reason why carbon is so nice for living things is how versatile it is. Carbon has space for 4 different bonds. So it's going to form a lot of different covalent bonds. So here we have carbon dioxide, where it forms 2 double bonds with oxygen atoms. And so we have CO2. We can have it in proteins, where we get this big chain of all of these carbons together. Sugars, we get these ring structures. Because of all the different bonds that carbon can make, and because it has 4 bonding sites, it can do a lot of different things. And so we see it in a lot of life's molecules. Okay. Anything with carbon, hydrogen typically is referred to as an organic molecule. Again, it can make tons of different types of molecules. And so we see in this beta carotenes transmission making vitamin A, we've got a lot of carbon in here. and that carbon is kind of the backbone of most organic molecules. Okay. So again, carbon can make a lot of different types of bonds because it's so versatile, because of the number of bonds that it can make. All right, so jumping into these organic molecules, these molecules that we see in living things. Okay, we've got 4 major categories of organic molecules. We have carbohydrates, proteins, lipids, and nucleic acids. So we'll go through each of these individual types of organic molecules. Okay. But before we can jump into these types, we have to figure out, how do we get these molecules? How do we go from elements to molecules to these larger, what we call macromolecules? Okay. And so this is going to happen one atom or one molecule at a time. We can't just make a huge chain out of nowhere. So what we see is that we put together monomers, which are our subunits. These are the individual components of these larger macromolecules. And this process is referred to as dehydration synthesis. So what we see here is we've got these 2 separate monomers down here. And dehydration, if you think about that word, when you're dehydrated, you don't have enough water. So in dehydration synthesis, dehydration, we're going to remove a water from those subunits. And so here we see we make that water. And then synthesis means that we're building something, we're making something. And so we make a new compound by taking water out of it. So we pull a hydrogen from one of those monomers, pull a hydroxide from the other monomer. Those bond together to form water. And then we get, in this case, this is a disaccharide. So it's a 2-part molecule here. Okay, so we're just chaining together our subunits here. And so we put these 2 together, and then we add another and another and another until we get that full chain. Okay. Now, to get these subunits, we have to break apart large molecules. Now, unfortunately, we can't consume a protein, say, from an organism and then immediately utilize that protein. We have to break that down into all of its subunits first, and then we can use those subunits to make our proteins. Okay? So the process in which we break things down is hydrolysis. So here we see we have this water molecule, and it essentially inserts itself to break these 2 parts of this macromolecule into its subunits. And so that's hydrolysis. So hydrolysis breaks things down. We'll see this word lysis quite a bit, and that's just a breakdown. Okay, so hydrolysis, we're using water to break things. Dehydration synthesis, we're removing water to make things. Okay, so we've got our monomers, which are our single subunits, and then polymers are when we chain a bunch of those monomers together. Okay. All right. So this isn't displaying quite correctly on my computer right now, but this is just going to say the process to build molecules, dehydration synthesis, process to break them down, hydrolysis. And we do this with these monomer subunits. Okay. So we'll leave it there. Just a nice, quick little beginning to chapter 3, and we'll pick up with our types of organic molecules in the next video.